in my previous video I explained how diodes work and how their graphs look like. We saw there that the current can only flow in one direction, which is this direction. The current was not allowed to flow in the other direction. But the diode has a big brother, and we call that brother the Zener diode. The Zener diode has a look like this. We just have to add two little lines and now we have a Zener diode. But my drawing isn't complete yet. I have to add a voltage and make, for example, let's say we have a voltage of 3.3 volts. But what does this voltage mean? It means if we add a voltage of 3.3 volts in the reverse mode, it means positive side there, minus side here, and it is 3.3 volts, the valve will open or the Zener diode will pass through the current. I will first draw the graphs so it will be more easy to understand. So, this one is the current, so the other one has to be the voltage. If the voltage is polarity is correct, then we have this. We go to the right because this is positive voltage, it is negative voltage, and there will be no current flowing until we reach 0.6 volts. That's correct. The Zener diode works like a normal diode if the polarity is respected, which means the plus on the plus and the minus on the minus. But what happens when we reverse the polarity of the voltage? I will do that for the Zener diode with 3.3 volts. This is 1 volt, 2 volts, 3 volts, and let's say this point is 3.3 volts. Okay, let's do it again. There will be no current flowing until we reach 3.3 volts, and there we see the current is able to flow. So we see the Zener diode can pass through current in both directions. That is a huge thing in the world of electronics. Let's draw this in a schematic. Let's start with step 1. I will add a voltage source of 10 volts, resistor of 10 ohms, then I will add the Zener diode, and back to the source, and this Zener diode has 3.3 volts. Okay, so my question is, how many current is flowing in this circuit? Okay, current equals voltage divided by resistance. How many volts is across this diode, resistor I mean. But first we have to look at the Zener diode and we see that the Zener diode is his polarity is correct, which means it needs only 0.6 volts to open the valve. So here we only have 0.6 volts. That means over here the voltage is 9.4 volts. So we have in the formula 9.4 divided by 10 is 0.94 amps. Pretty easy. But what happens when I switch the Zener diode? So now I change the polarity of the Zener diode. So what will happen now? We see the Zener diode needs 3.3 volts to open. So okay, no problem, our source is 10 volts, so it can easily give 3.3 volts. So the voltage across this resistor equals 10 minus 3.3 volts equals 6.7 volts. So the current must be 6.7 divided by 10, 0.7667 amps. Okay, let's make this a little more interesting. Let's say we decrease the amount of voltage from the source, 5 volts, and we increase the voltage that's needed to open the diode like this. So now the Zener diode needs more voltage to open than the source can give us. So what will happen now? Okay, how many current will be flowing? Or where will we measure voltage? That's a better question, I think. So this one needs 6.7 volts to open. We only have 5. So the source will give all his voltage to this Zener diode, and there will be no voltage to be measuring across this resistor. So again, if we put it in a formula, the voltage across the resistor is 0. 0 divided by 10, that's 0 amps, so there is no current flowing in this schematic or in this circuit. Let's make this a little more complicated. And let's say we have a voltage source of 10 volts, let's say 20 volts. I will put one Zener diode correctly and one Zener diode reverse. This Zener diode, let's say 3.3 volts, and the other one also 3.3 volts. 10 ohms. So again, my question is, how many current will be flowing in this circuit? So we first have to question us, what's the voltage across these Zener diodes? We see one polarity is correct and one is in reverse. So the correct one, we know, 0.6 volts. So over here we have 0.6 volts, and the other one is not equal to 0.6 volts because it's in reverse. So it means we need 3.3 volts will be across this Zener diode. These two are in series, so we can simply add those two voltages together. And now we have 3.9 volts across both of our Zener diodes. This voltage is needed for the Zener diodes, so there will be only 16.1 voltage across our resistor, and now we can easily calculate our current, which is 16.1 divided by 10, 1.61 amps, just by that. Thank you for watching.